We are ready to start to manipulate expressions. And when we go to manipulate expressions, one of the questions that we want to ask is, what sort of manipulations are actually legal? And in order to answer that question, we need to ask, what is it that we're trying to accomplish when we manipulate an expression? Let's consider the example of a simple arithmetic expression. So here we have the expression 2 times 3 minus 5. There are a couple of manipulations that might occur to us to do here. One, we might do a step in evaluating this expression. So we might take 2 times 3 minus 5. 2 times 3 is 6. And that works out then to 1. The bit where we multiply 2 times 3, the bit where we subtract 6 minus 5, these are the kinds of things we like to do to expressions. Another thing that we might do with this simple arithmetic expression is to rewrite the subtraction as adding the opposite. So we might say 2 times 3 minus 5 is 2 times 3 plus negative 5. That's another kind of manipulation that we like to do to an expression. What is it that all of these things have in common? They keep the value of the expression the same. In other words, the expression continues to represent the same number as we do all of these manipulations. As we expand to work with variable expressions, that continues to be our goal. That as we manipulate them, the expression continues to represent the same number. But that's a little bit more complicated with variable expressions, because in a variable expression, the value of the expression depends on the value of the variable. If we want a variable expression to continue to represent the same number, but that number depends on the value of the variable, well, how can we make that happen? The answer is, we want to get expressions that represent the same value, no matter what the variable represents. Such expressions are called equivalent expressions. So, for example, the expressions 2 plus 3 plus x and 5 plus x are equivalent expressions. Why? Well, the first step in evaluating this expression would be this first addition, 2 plus 3, and therefore, no matter what x is, we'll add 2 plus 3 first, and then add x to it. On the other hand, the expressions x plus 2 and 2x are not equivalent. Why not? Well, if x represents the number 4, the first expression evaluates to 6, the second expression evaluates to 8, 6 is different from 8. So it's not the case that x plus 2 and 2x represent the same value no matter what x represents. In particular, if x is 4, they represent different values.